Black holes. The only way you can see a black hole is if you used a telescope and looked really closely into space. Because of gravity, nothing, including light and radiation, can escape. Therefore, you will only know if you are looking at a black hole if there is a black circle with stars surrounding it. Surrounded by an outer event horizon that marks the point of no return, all items that enter will never return. Although, if you fall into a black hole, it's possible for you to see someone from the other side that has also fallen in. Although there are multiple theories, the most common one is when a star with a larger mass than the Sun comes to its end. Because it cannot create enough nuclear energy to sustain itself, it gets crushed under its own gravity and creates a black hole. Once the star begins to die, which is the supernova explosion, the process of becoming a black hole takes millions of years.
In order to escape a black hole, you would have to be traveling faster than the speed of light. Once you have entered it, you would be sent flying into the center. If you are flying head first, the gravitational pull in your head will be stronger than in your toes, causing you to stretch. This pull, the tidal force, would be stronger than the chemical bonds holding your body together. Nobody really knows what happens to your body after you reach the center.
So this is an example of a black hole. As you can see, all the water is just getting sucked in, and it's not going to be able to come back out.
A wormhole is a structure that connects two regions of space. This is why they were once known as a bridge. It is created the same way as a black hole, when a massive star explodes. A wormhole is a two-dimensional surface folded on the third dimension. A wormhole is theoretical. They are like a doorway through space. Wormholes are also called the Einstein-Rosen bridge.
White holes. Unlike black holes, white holes cannot be entered, but is constantly spewing out matter. A white hole will collapse under its own weight almost immediately. Therefore, they are not as stable as black holes. White holes have to be created in a supernova explosion, and yet there were no supernovas there for it to have come from. Black holes are formed by the collapse of stars, but white holes shrink from matter, so they cannot exist in a connection with true black holes because their presence of matter would cause them to collapse. Okay, so this is an example of a white hole. As you can see here, the water is pouring down and it creates a barrier, almost like an outer event horizon of a white hole. And so all the water is coming out and it can't get back in through this barrier. It just goes around it. And all this water just keeps coming out and it can't come back in.
Quasars. Quasars have a very high redshift. They seem to inhabit the centers of active young galaxies and can emit up to 1,000 times the energy output of our entire galaxy. The most luminous quasars radiate in excess of the output of 1 trillion suns. Infrared telescopes and the Hubble Space Telescope have identified the galaxies surrounding the quasars. These galaxies are normally too dim to be seen against the glare of the quasar otherwise.
Black holes is where it'll start. About 2,000 miles far. When stars explode is how they start. It's just like a white hole, but the opposite. You will never get sucked in. It's a black hole. To get back out, it's impossible.